Welcome to a lesson with Dr. Powell. In this video, we're going to have two practice problems for explaining how the sandwich theorem can be used to determine the limit. So first, you can see the problem here, and pause the video so you can work on it, and then keep it going to see the solution. Okay, so we're going to look at problem number one. Ready? Go for it and pause the video. Okay, now here's the solution. So to use a sandwich theorem, we're going to think of this expression right here as being sandwiched with an inequality between two other ones. To do that, we're going to look at the part that's variable, cosine. Cosine jumps between -1 and 1 as x heads off to infinity. So basically that means that this whole top part will be basically jumping around between a finite range. So numbers in a finite range over x as x goes to infinity. Obviously, numbers that are finite in a restricted range or a restricted spot interval divided by something becoming infinite, that'll go to 0 for sure. So the limit should be -17. But how do we explain this using the sandwich theorem? Well, we use the variability of cosine x. It's sandwiched between -1 and 1, which means that cosine x minus 3 is sandwiched between -4 and -2, because you can kind of think of it this way. So cosine, let's see here, let's do it a little more clearly. So cosine of x is sandwiched between -1 and 1. So then if we subtract 3 like that. So that's going to be sandwiched between -4 cosine x minus 3 and -2. Now we multiply that, and then so that's cosine x minus 3. Multiply all that by 4. We would end up getting -16 is less than or equal to 4 times the cosine of x minus 3, and that's less than or equal to -8. Okay, so we get right, and then what we do is now x is going to be a positive number heading off to positive infinity, so dividing by a positive number will not change the direction of the inequality ever, so we have just divided by x, so this works. And then in all these inequalities we can just add -17. 17 plus, or well, we could just write -17, I guess. And maybe just to make this more clear, we can go like this, and let's see, right, -17 less than or equal to, and -17. What we've done is we've sandwiched this whole expression that we're taking the limit of in between two things, right? Just between this guy right here and this guy. And notice what's better about these things is that these things aren't jumpy like this cosine x, right? It's not wobbly as in heading off to as x, the denominator is going to infinity. This is a fixed numerator right here, and x is heading off toward infinity, so this part definitely will go to 0, which means that this side goes to -17, and then right here this part will definitely go to 0, which means that, and this part going to -17. So we get -17, so this part, this whole side goes to -17, this whole side goes to -17, which means what's in the middle must also limit to -17. Okay, so that's a description using the sandwich theorem, how to use sandwiching in order to explain or show why the limit, this first limit, will be -17. So that concludes the discussion for that one. All right, now we're going to get ready for problem number 2 here. do a little erasing as we go. Okay. All right, so let's take a look at the next guy, number 2. Okay, are you ready for this one? On your mark, get set, pause the video and go for it. Okay, now here's the solution. Okay, so we're going to be looking at cosine. That part will bounce around between 1 and -1. So let's just write that down. And our goal is to come up with something that this whole thing is sandwiched between. So, but we know what cosine of x minus 2 will be sandwiched between. It'll be sandwiched between 1 and -1. Now, in particular, you see what's coming into the cosine? It's 1 over x minus 2. And look, it's coming on both sides. Now, the graph of 1 over x minus 2 is just the graph of 1 over x that's been shifted to the right 2. So it looks something like this. And in looking at that, notice on one side the input's heading toward positive infinity, and the other side it's heading down toward negative infinity. So as we're getting close to 2 from either side, it's bouncing around a lot. Just kind of keeping that in mind as we go. So we get so that's why sandwiching is nice, because we're going to be putting the whole wobble between -1 and 1. All right, now what do we have here? Then what we're going to be doing is we're going to be multiplying everything by x minus 2 quantity squared, which is going to be a positive number, so that the inequalities will be preserved as we do so. So what we're doing is like building this expression from the inequality here. So x minus 2 quantity squared times x minus 2 quantity squared. Then we can just simply add 4 to everything. 4. Notice that we've just sandwiched our original expression between 2 other ones. This one and this one. Now, as x approaches 2, this part goes to 0, which means this whole part will go to 4. Likewise, this whole part, -1 times that goes to 0, so when adding 4, it's just going to go to 4 as well. Since these parts go to 4, then this middle part will also go to 4 by sandwiching. And that's explanation of using sandwiching in order to compute this limit. Thanks for watching.